For this video, we'll be doing 8.1 number 10, which asks, what is the total area of the shaded region? So we're going to try to find this area right here. So first, let's just try to find a formula. So this area of the shaded region is made up of triangle DEC and triangle ABC. So we can do area of the shaded region is equal to area of triangle DEC plus area of triangle ABC. And we know that the area of a triangle is just 1/2 base times height. So the area of the shaded region is 1/2 base times height. And we'll just do the base of DEC is just base for now, so we don't know the answer. And height is y. And then the 1/2, the base of ABC is 8. And the height is x. So the area of the shaded region, let's just simplify now, is equal to 1/2 base y plus 1/2 8 is just 4x. So that's our formula we'll be looking for. So now let's try to find the unknown variables. So let's try to find the base first. So let's find base of triangle DEC. So to do that, we can do some similar triangles. We have a triangle here and we have a triangle here. They're going to be similar. We know that that's what's given to us is that DE and AB are parallel. That's already given to us. So DE is parallel to AB, which is given. So from there, we know that angle CAB, this angle, is congruent to DEC. So angle CAB is congruent to DEC by alternate interior angles. And the same thing, we can say that EDC is going to be congruent to CBA by alternate interior angles as well. So now that we have two angles that are similar, are congruent, we can say that these two triangles are similar. So triangle EDC is similar to triangle ABC by angle-angle similarity. So now that we know they're similar, we can find a scale factor that makes them in common. So this similarity shows corresponding sides. This just shows that BC is similar to CD. And it also shows that DE, so this is similar to AB, which also shows us, which will be helpful later, is X is similar to Y. So let's use what we know. We know that BC is similar to CD, so let's just find a scale factor. So BC is similar to CD, so if we do BC over CD, which is equal to 10 centimeters over 5 centimeters, we know that this is going to be 2. So the scale factor is 2. So now we can use a scale factor to find what the base is. Since we know that AB is similar to DE, since we found that before, we can use a scale factor to find out what DE is. So we know that AB over DE has to equal 2, which is the scale factor. So then we know that AB is 8 and DE, we know that it's 2. So then we just have to do our math. So we can do times 1 over 8 times 1 over 8 to get 1 over DE equals 2 over 8. And then we're just going to flip everything. So DE equals 4. So I'll put this on the side. DE equals 4. Nice. So now we know the base. So now let's look for y and x. So to find x and y, we'll also have to use this kind of similar triangle knowledge. So we know that x is similar to y. We did that before, that these triangles are similar. And we also know that x plus y equals 9. So this x plus y equals 9. And we also know from the similar triangles that these have so x times 2 equals y. So we can say that x is equal to 2y because of the scale factor relationship. So now that we can just substitute everything in. So x plus y is 9. And we know that x is just equal to 2y. So 2y plus y equals 9. We know that 3y equals 9, just simplifying. So y equals 3. We'll put that to the side. That's one of the variables we needed to find. Now let's just plug back into the original formula to find x. So x plus 3 equals 9. So x is equal to 6. So now we have all the missing variables. We have the base, we have y, and we have x. So now all we have to do is plug everything in. So now it's to find the area. So the area of the shaded region is equal to, so back to our formula, is 1/2 by plus 4x. We know that the base is 4, y is 3, and x is 6. Now all we have to do is simplify. So you have 1/2 12 plus 24. 1/2 of 12 is just 6. And then 24 plus 6 is 30. So the area of the shaded region is 30 centimeters squared, since that is our units. And there we go.